Hello and welcome. We are in Unit 5 for the graphing. This is the video for 5.2 substitution tables and their connection to graphing. So it's important for us to make sure that we add our name and date onto this. So please make sure that you add your name and date. And we are indicating some information with this. This is a preformed fill-in-the-blank sheet, so make sure you have your sheet in front of you. If you do not have your sheet with you, you may download it from My Big Campus. Okay, so here we go on some vocabulary that we are familiar with. So these first 5 words we've been using a lot, so they're pre-written for you. So coordinate graph is a visual way to display data between 2 variables. A variable is a quantity that changes or varies. An ordered pair is a data point that shows a location on a graph. We're definitely going to be using this piece today. And independent and dependent variables will also be highly used. The independent variable is the input data, and it goes on the x-axis, and the dependent variable is the output data. And it depends on the input data and goes through a process, often with the operations. We'll show you those momentarily. And this part, the dependent variable information, goes on the y-axis. So here we go to start us off with substitution. We write down that this is a process that we place values into the input, and then we evaluate this to get an output. So we're going to place one value on the input, do whatever it's asking us. There's multiple operations because we're going to be using equations, so whatever the operations are telling us to use, and then we're going to get the output for that particular input. And we will be working with functions, and so functions are a machine in which we get one, it gives us the output values when we substitute values for the input. So the substitution process really helps us when we're working with a function because it's this machine that we're working with in order to get the output for each and every one of our inputs. So now we're going to take a look at the process and the key concepts. So we're looking for a method to create a substitution table. And we're going to start off with identifying the independent and the dependent variables. So first step, we identify the independent, dependent variables. Second step, we're going to create a 3-column table. And this is going to be a 3-column substitution table. Substitution. And the third step is going to be filling in the input values. And these could be either given to us or they could be chosen for us. The fourth step is to use order of operations. So we're going to use order of operations to evaluate the output for each input. The fifth step is going to have us graph the input and the output pair as a point on the coordinate plane. So when we write these, we write them as ordered pairs, and we always put the x first. So it's x comma y, and we put them in a bracket of parentheses and a comma in between them. The sixth step is to connect the point with a smooth line or curve if it's appropriate. So I really want you to make sure that you are recognizing if it's appropriate. There are times when we've worked and it's not appropriate to connect the points. Some of the real life data we don't want to connect. So make sure that we're taking a look to see, does it make sense? So not all the data makes sense to connect. And we're graphing either real data or possibly model data. These are some items to check in. Is this real data and does it make sense to connect? Or are we just making a model, being able to estimate certain items? Is it possible to have increments or in between the data that we already have? And now we're going to take a look at our first example with the substitution table. So we have this key concept. We're going to use the method through. So we're going to start out with the first example of y is equal to negative 2x plus 3. Now here, when I take a look at this, I have an equation and I have an x and a y. The y is my dependent variable and the x is my independent variable. And so we're going to place the independent variable as the x in this 3-column table, and the y is our dependent. Hold on, whoop, getting a little fast there. Let's back that up. Okay, so if we take a look at this, we have the original equation, y equals negative 2x plus 3. I'm creating this 3-column table, and it's going to have an input. The middle column is going to be the part that I've highlighted and circled in yellow, rather. And that is this process of the use of the different operations. So it's telling me that I'm going to be multiplying my independent variable by negative 2. And then, because order of operations tells me I need to multiply first, then I'm going to add 3. So that's why order of operations, I put that in there. It's super important that we make sure we can recognize what's happening to the variable. Now when I've got this going, we can take a look, and I'm going to start to identify some input values. So in this case, I usually go from negative 2 to positive 2. And if it doesn't tell me or doesn't stipulate or there's no fractions, that's really my standard go-to, is I go from negative 2 all the way to positive 2. It's my standard when I'm trying to graph, because it's data that's fairly close together but also gives us 5 data points. So when I do this, I have this function. It's a machine. And so I'm always going to be multiplying by negative 2 and adding 3. So I'm going to write out this concept of this function for each one of these input values. So negative 2 times whatever my input is plus 3. From there, I'm now going to start to actually work through and substitute the value that I want to put in. So to start with, I'm going to put negative 2 into the first set of parentheses and say negative 2 times negative 2 is positive 4. And then I'm going to add 3 and give my output value of 7. Okay, let's continue down the tables. So I'm now going to put in my input value of negative 1. So I'm going to say negative 2 times the input of negative 1 plus 3, giving myself positive 2 plus 3, ending up with 5. The next one, we're going to plug in 0, and 0 times anything is 0. So we're going to have 0 plus 3, and I'll get 3 for my output. My next input's going to be a positive 1. I'm going to plug that in. Negative 2 times positive 1 gives me a negative 2 plus 3. And we went a little fast there again. We're going to back up. Hold on, let me get back to it. All right, there we go. We're back to the first piece. And we have negative 2 times 1 giving us negative 2 plus 3. And that's going to give us a positive 1. So make sure that we're also indicating our integer operations, because you'll notice that up here we're multiplying two negatives together and it's giving us a positive, and down here we're multiplying opposite signs and it's giving us a negative. So the integer operations are important, along with when we add integers, they have different rules. So when we add integers, we essentially identify which is the larger number, and that larger number is going to win out. So the 3 is bigger than the 2, and so that's why we have a positive answer. So make sure that you're indicating those integer operations as well as the integer rules with our positives and negatives. So the last value we're going to work through is 2. So we're going to take negative 2 and multiply a positive 2, get negative 4 plus 3, and we get a negative 1. Now we're on to our 5th step of placing these into ordered pairs and then graphing them. So as I put these into ordered pairs, I always start with an x comma y. X value always goes first, and lucky it's on the left-hand side of this table. That is done strategically, so it's kind of organized in the way that we want to write it down. So we're going to always keep this for all of them, where we have parentheses and then a comma in between them. So we'll start with negative 2 comma 7, and we place that by going 2 to the left and up 7. So these are directions, remember. So we start at the origin, which is right here at 0, 0. So that's our origin. We always, we don't ever write the dot there unless we actually have that ordered pair, but we always start right there. That's a huge piece for us. So our direction is to go 2 to the left and then 7 up. And that's where we're going to actually write our point. So that's how we indicate this and find those items. And we've been graphing real life data, so that makes sense for us. When we work with the next data point, we're going to write in negative 1 and 5. So we're going to go 1 to the left. So fast. We're going to go 1 to the left and 5 up. So you can see that on the graph. Then we'll graph the data point 0, 3. And that, you notice, is right on the y-axis. We call this our y-intercept. It's where this line or the data point actually hits the y-intercept where x is 0. The next one we have is 1, 1, so we're going to go 1 to the right and 1 up. And then we have 2, negative 1. So we're going to go 2 to the right and down 1. In this case, because we're not given real life data, it would make sense because we're working with a model. So with this model, we can connect these dots and put arrows on either side of the line. Make sure that you're using a straight edge. You'll take a look. This should be a straight line. In fact, in all this video, this should have straight line pieces in this particular video. Okay, let's take a look at our second example. So we're going to flip this over. Pause the video at this point if you are not ready to move on and you want to add in some extra data pieces that you haven't yet written down. So for example number 2, we're going to take a look and we're going to use the function y is equal to 2/3 x minus 5. Now we've got this dependent variable of y and an independent variable of x. So we are going to create this xy chart. It's a 3-column table placing 2/3 x minus 5, which is our machine, and tells us what operations to use in the center. So from here, we're going to organize and use particular data points here. So when I write this together, again, I have my input for the x, and my output is happening for my y. You don't have to write that down. I just want you to pay attention to those pieces. Now, I'm particularly picking, I'm going to repeat again, you don't need to write down the input and the output that I've written here. Now, I've chosen values that are multiples of 3 strategically. This is a huge important piece for us. When I take a look at my x values, my input values, again, they're multiples of 3. You've got negative 6, negative 3, 0, 3, and positive 6. The reason is because we have this fraction and the denominator is 3. I always, when I have a fraction that's in front of my input that I'm multiplying, I always want to use multiples of that denominator. So it's not always going to be multiples of 3. If I had a fraction of 1/4, I'd use multiples of 4. So be really careful about that when you are not given the x values for the input and you have to choose them, particularly when you have this denominator. Okay? So now we're going to use our skeleton of 2/3 times x, so whatever our x is, minus 5. And we're going to throw that into all of these, and we have 5 data points we're working with. So we're going to put it in all 5. Okay, so this is our skeleton of that machine, that function machine that we're working with. So each time we're multiplying by 2/3 with our input, and then subtracting 5, because order of operations tells me I need to multiply and then subtract. So in doing this, I'm going to now put in each piece. So we're going to start with that -6. So when I do so, you'll notice that, I'm even going to go back, you'll notice that the 3 and the -6 can cancel, because what we get to do is 6, or rather -6, can be written as a fraction. Any integer, in fact, can be written as a fraction if divided by 1. So that is what is indicating and letting us know that we can do that. So if I go here, and I could even put it in a nice bright color so we can see it, divided by 1. Okay, that fraction, or that integer rather, can always be written as a fraction. So that's what allows me to do this. And so there is 1, 3, and 3, and a -2, 3's, and -6. So I'm going to place those down there, and we're going to move into multiplying then 2 times -2. So in fact, we made those denominators cancel, and then subtract 5, of course, at the end. This gives me -4 minus 5, so I get a -9 for my output answer. So this function machine is really working for me. I'm going to now plug in a -3. So these cancel, and I get a -1 for there. So 2 times -1 minus 5 gives me -2 minus 5. I get a -7 for my output. Okay, still working with these inputs. I'm going to put 0 in. Lucky for us, 0 times anything is 0. So 0 minus 5 gives us a -5. We're now going to plug in the 3. So the 3 on the top and on the bottom cancel, giving me 2 minus 1, or 2 times 1 minus 5. Gives me 2 minus 5, finishing off with an answer of -3. Then we're going to have 2/3 times 6. There are 2 3's and 6. So 2 times 2 minus 5, 4 minus 5 gives me a -1. Now I'm going to go ahead and work on the graphing of this particular function. So I'm going to identify what my x and y's are. But first I'm going to clear out this input-output just to give myself a little extra space. So I'm going to erase those. Those are now gone. And we're going to indicate that xy chart. So x comma y in parentheses. So we're going to set that stage for all of our 5 data points that we've now created. And we have -6, -9, -3, -7, 0, and 5. So for those 3 data points, I want to make sure that you get a chance to identify where those are. So if I look again on this chart, -6, I go 6 to the left, and then down 9. Okay? That's that first point and how I get there. Again, they're directions. These are not actually making points other than the result of where I finish up for these directions. The next guy, it tells me to go 3 to the left and then down 7. Okay. And then at 0, I don't go left or right, I just go down 5. Okay, that's how I'm going to graph those 3 points. Now I've got 2 more points to go. So I'm going to indicate 3 and -3 next. So I'm going to go 3 to the right and 3 down. And my last data point that we've created in this substitution table is in fact 6 and -1. So I'm going to go 6 to the right and 1 to the left. Again, we're using a real life situation, or we're using a model. It's not a real life situation. We weren't given a story or an indication of what this means. So we can connect these dots. And even if it was a real life situation, there are times in which it would be appropriate to connect the dots. Make sure you add the arrows onto each end of the line. I will be checking for that when I get back. And let's take a look at example 3 and 4, which are going to be started for you and trying on your own. So example 3 at the end is the equation y is equal to -4x. I'm going to set up this table for you and you're going to finish it off for us. Okay. I am going to give you the values I'd like you to use. So we have an input of x, an output of y. Our function machine we're using is -4x. And we're going to use only 2, pardon me, let me go backwards a moment. We're only going to use the input values that you see over here. We're going to use these guys. So -2, -1, 0, and 1. So I'm going to give those to you so that we can make sure that we're all on the same page. If you picked different ones, it doesn't mean that it wouldn't give you the same line, but I want to make sure that our order of operations and other items that we're working with, integer rules and such, are matching what we really know. So we're going to use these. And I'd like you to complete the skeleton. So we're going to write in -4 and times whatever it is that our x input is going to be. So again, this is our skeleton drawn for this machine, and we're going to be plugging and chugging. So with that plug and chug, you are asked to please finish the table, write the ordered pairs, and graph. We have one more that is going to be a more complete try on your own, in which you're going to finish this with a little less framework from me. Again, this should end up being a straight line, and in fact it is a -4 as the slope, so it actually should be a negative line when we read it from left to right. It's another indicator that you're working through this. So example number 4 is what we're going to indicate next, and this again is going to be a try on your own. Okay, and we're going to use the equation y is equal to -4x plus 1. You should get similar answers to what you had in example 3, but they should have a little twist, because now we're going to indicate this plus 1 piece. It's not just going to be the -4x. We're now going to have the entire piece of -4x plus 1. It's going to have a little bit of a twist to it. So again, I want to make sure that you're using those values I want. So let's use a table of x and y. Make sure you identify those pieces. And I would like to give you the values for this. Again, we'll use -2 all the way through +2 for integers, to make sure that we are using our order of operations correctly when we're evaluating this function. So again, machine, make sure you multiply, and then we add. This should give you a straight line when we go through. Identify those ordered pairs and create your line. We'll go over this in class next. Thank you very much for your attention.